Hello, I'm Alan Taylor and I'm delivering the presentation Industry 4.0 Digitisation of the Normanton Steel Plant at the Materials Processing Institute. I'm following the following agenda. Firstly, I'll give an introduction to the Materials Processing Institute and the project itself. Then I'll discuss the Normanton Steel Plant main facilities, how we selected an Internet of Things platform, moving through to areas of improvement, PLC network upgrade, sensors and equipment upgrade, going all the way through to discuss application of augmented reality before finishing with a conclusion and further work. This is an aerial photograph of the Institute. The Institute was established in 1944, firstly as BISRA, then became British Steel, Chorus, Tata, and then became the Materials Processing Institute in December 2014. The Materials Processing Institute is independent, it's not for profit, develops new technology processes, improvements in steel grades, working with the materials sector globally. We're separated into 4 distinct research groups. Firstly, advanced materials, low carbon energy, the circular economy, and digital technologies, of which I'm a member. The vision was to create an open access Industry 4.0 demonstrator for the steel and process industries, utilising the Institute's Normanton Steel Plant. For this we obtained Innovate UK funding under a project called INTIFY, which stood for Industry 4 Technologies into the Foundation Industries. We had several partners. There was Liberty Specialty Steels UK, Liberty Hartlepool Pipes, TSC and Shiftech. Now the UK already has demonstrators for Industry 4.0, however these are at the catapult centres, but these were purpose-built from the ground up with Industry 4.0 in mind. Therefore they avoided the issues of legacy equipment, ageing equipment, multiple data formats, which will be faced by all process industries, not just the steel, as they attempt to apply Industry 4.0 technologies. The challenge, therefore, was applying Industry 4.0 technologies to the Materials Processing Institute steel plant. By doing that, we explore the issues involved in retrofitting existing legacy kit with digital technology. Further, digitisation of the steel plant requires connection of existing process monitoring equipment together with retrofitting new equipment and digital technologies, thereby exploring the technology challenges involved in the harsh environments experienced in the steel and foundation industries. Having done this first at the pilot plant, this allows smoother transition of these technologies to other steel partners and foundation industries. The Normanton Steel Plant consists of a 7-ton electric arc furnace, combined vacuum degassing and ladle furnace, and a continuous caster capable of casting billets and mini slab. Depending on the section size, these vary in length from 15 metres to 36 metres. They're suitable as direct mill feed, and we also produce ingots, 5 tonne and 5.9 tonne square. The first thing we had to do was select a suitable industrial Internet of Things platform. We initially considered developing our own using Microsoft Azure. However, we performed a survey and review of existing industrial Internet of Things platforms. From this we chose to evaluate the Siemens MindSphere and PTC ThingWorx. There's a long list of required functionalities and some included below, such as the ability to store data from several edge devices, process in real time, ease of connection to multiple large data sources via OPC UA, ease of adding code to the platform, speed of implementing modifications and new sensors, ease of dashboard creation, ability to export historical data, event recognition and alarms. And one of the key things we wanted from such a platform was the ability to perform data analytics on the platform together with the development of machine learning and artificial intelligence models. And of course another key function would be the cost and customer support. Having trialled the platforms, we chose PTC ThingWorx version 9. It met all our criteria, but also had good connectivity to Kepware version 6. Kepware server is used on our steel plant, It is a connectivity platform having many protocols to allow it to connect to various sensors, instrumentation and PLCs. The data was stored in PostgreSQL, open source database for ThingWorx. Both ThingWorx and PostgreSQL were placed in a secure firewall DMZ. This allowed external workers and project partners to securely view live melt and cast data together with live video streaming of the process. Further, it allowed the ability to connect to external customer databases and Kepware servers for data transfer and modelling. This is a simplified network diagram. On the left hand side you can see the DMZ. In the DMZ is the ThingWorx server together with its PostgreSQL. It's behind the Institute firewall to provide security. Down on the bottom right you can see the Kepware server, which collects all the signals from our steel plant. These signals then go up through the firewall and to ThingWorx and the database. Moving along from that, if we go up from the firewall to the router, go right, and we can see the home worker. He's behind a router and a firewall. He can connect to ThingWorx using SSL certificates and encryption to securely consume data. Moving up again, above him you can actually see the Kepware version 6, which is at the client's partner Steelworks. This can connect to our ThingWorx again over the internet using a secure connection to allow us to collect data, build mimics and develop models. Another area we started off on at first was looking for areas for improvement. We performed a detailed gap analysis to identify Industry 4.0 digitisation ideas. We developed a lot. From this we did process mapping and brainstorming jointly with process operators and research personnel. This project started on the 1st of April 2020, right at the commencement of the pandemic and lockdown. So all these brainstorming activities were performed remotely using Teams. Following the brainstorming, we identified areas for improvement. We scored these on benefits and ease of implementation. What we found was, as the steel plant is used for several different purposes, it resulted in different benefit scores between research and process users. Having done this process, we selected the low-hanging fruit in that we chose high benefits and ease of implementation to progress. Also as part of this process, we identified key performance indicators. And there's a list of some below, such as slab surface quality, fail starts, energy, availability. A key requirement for Industry 4.0 digitisation is a reliable and secure network for transmission of signals and instrumentation. We first upgraded the PLC network from ControlNet to Ethernet. We used dual port cards to create a redundant ring and provide a more secure and fault-tolerant system. By using Ethernet we had better system integration. We also installed a wireless network in the steel plant to allow communication with wireless sensors, tablets, for process and maintenance engineers. The tablets allow process engineers to have access to process information, measurements and advice, and the maintenance engineers access to maintenance records and equipment manuals. As part of the areas of improvement, we identified additional sensors that would be required. The sensors covered various measurements, firstly temperature, using thermocouples, Casa strand parameters, thermal camera, pressure, flow, energy, weight and steel analysis. So we had to connect existing sensors as well as the new sensors to the PLC network and through to the Kepware and ThingWorx. Some legacy equipment, together with other equipment such as the strand parameters, require the development of edge applications. We're still in the process of upgrading a lot of the sensors and connecting them. Once fully connected, these sensors will allow the development of machine learning, artificial intelligence models for predictive maintenance, operators' advice and product quality. We also explored the use of Arduinos to allow secure connection to wireless mold thin thermocouples. We developed various mimics and data displays. At the top left you can see a mimic for the caster together with its relevant information. These were developed using Java mashups on the Internet of Things platform. We also developed data displays. On the top right we have live EAF line currents. Bottom left, EAF power and steam display. and on the bottom right, live caster mold temperatures. These are just a few examples from the network ThingWorx server. Because of the network connectivity that we had set up, it allows remote viewing of casts. So here we have Digital Technologies Research Group's manager, Chris Oswin, and on his left-hand monitor, he's got a caster mimic, and it's consuming data from a live cast, and at the same time we can view the cast as we installed CCTV system. This will also allow our partners and clients to observe casts as well remotely. As part of the project, TSC Simulation performed a laser scan of the pilot plant, and this is a short video showing the laser scan that they created. I would like to actually point out that this is not a video, this is actually a laser scan, and you can navigate it using an Xbox 360 controller. So it's just a short video. It shows the pilot plant and it shows the ability to move around. At a later stage we'll be able to add further information, labels and measurement signals to this as we put it into a digital twin. Within this navigable laser model we're also included photospheres, so you can stop at certain points and do a 360 look around. And this video shows this happening. We're moving towards a photosphere. As you can see the square, you enter the photosphere and you can do a 360 degree look around at that location. The plan on the top left shows spheres, and these are where the photospheres are located. We also investigated the application of augmented reality to the steel and metal sectors. And for this we purchased Vuforia suite from PTC. This came in various guises and provided firstly remote assistance using Vuforia Chalk. This allowed video calls with annotations to be anchored to the image to be made, and I've got some video showing this later. Provides enhanced training using augmented reality with Vuforia Expert Capture. So we can develop training materials which can be delivered via smart glasses or mobile devices. This also provides data animations which can be superimposed onto items of the plant equipment. We also looked at enhanced data presentation through the operators using Vuforia Studio. So we can target information in operators' line of sight via smart glass technology, and information can be linked directly to what the operator is looking at. And we're also looking to using this for promotional experiences using Vuforia Studio, so we can deliver virtual tours. I've now got some videos demonstrating some of this augmented reality. We're looking at using remote assistance using Vuforia Chalk. So if you look at the video on the right, if you could imagine we've sold a bit of kit to somebody in Australia and they want some advice and guidance on using it. The operator there can video the equipment using his mobile phone. The expert back at the institute can provide advice, and he can annotate onto the video. So you can point out which sort of valves need turning, what pressure gauges to look at. And the other good thing about this application is that the annotations remain anchored to the actual devices, so if the video moves away and moves back, they're retained there. What we're hoping this to do is that it should reduce the need to travel to remote sites, thereby saving money for both ourselves and our clients. We're also looking at Vuforia Capture, and this can be used for capturing the expert's knowledge. So the expert puts on some HoloLenses, then he can move around, and in this video we're actually showing the water modelling lab. So he can move around, perform all the actions that he would normally do, and record his actions. We can then add videos and text instructions to it. The person being trained up would put the HoloLenses on, and then the set of arrows will guide him to the location where he needs to be. Superimposed in his vision will be a video of the actual expert performing the operation of the equipment together with text instructions. Once he's completed the actions, the arrows will guide him on to another location. We think this is a very good way of capturing experts' information rather than just writing it down in the text format. We're also looking at superimposing real-time information onto operator's viewpoint. So here on the top right we can actually see information being superimposed using Vuzix smart glasses, and it's providing relevant caster information while the operator is actually looking at the caster itself. This data was recorded from an actual steel cast on the 15th of July 21. The slide below shows a researcher wearing the smart glasses, and on the left hand side is the smart glasses themselves. So this will provide timely information to operators so they can actually see problems arising before they occur and take action. We're also looking at augmented reality with the use of the LiDAR on iPads. For the LiDAR function, we can create a scan of the caster, which is shown here on the bottom left. Then we have a video on the bottom right showing that having done the scan, we can actually place useful information such as temperatures, measurements and pressures onto the tablets themselves, or they can actually be delivered using smart glasses. The operator can then look around the machine. You can see equipment that is labelled. You can also pull up technical diagrams of the bit of kit, as well as view process information. In this way, the process operators get relevant information in a timely fashion to help them make decisions. Conclusions and future work. The Institute is in the process of digitising its steel plant and applying Industry 4.0 technology. With the Internet of Things environment for secure and remote viewing of steel plant processes. We're going to continue the development of the ThingWorx platform in terms of pre-processing signals, creating dashboards and edge applications. We're equipped to provide big data analytics, machine learning and AI models for predictive maintenance, operator advice and product quality. We're in the process of developing a digital twin, and we've just started incorporating caster models and PLC models, and we'll move on to live signals. We've been exploring the use of augmented reality to provide real-time data and warnings to process engineers to allow them to make informed decisions and identify potential problems before they occur. Augmented reality for expert capture and to provide resistance is also being examined. Thank you.